Comet 3I Atlas crashes into Earth, and a wave of widespread destruction starts shaking our planet. Ginormous tsunamis are swallowing coastlines, devastating earthquakes are cracking the ground. Hot debris is igniting massive firestorms. Thick clouds of dust are blocking the sun. Now, that's what could happen if 3I Atlas, a massive comet traveling through the solar system, collided with our planet. But can this disaster actually occur? When will 3I Atlas be the closest to Earth? Let's figure this out. First of all, this comet turned out to be way larger than we previously thought. Its weight is likely a whopping 33 billion tons. Let's throw in a few comparisons to put it into perspective. The Eiffel Tower weighs about 10,000 tons. So, 33 billion tons is roughly the weight of 3.3 million Eiffel Towers. Impressive! Next, all the cars on Earth, and we're talking about 1.5 billion vehicles, each weighing about 1.5 tons, weigh approximately 2.25 billion tons. This means that the comet's mass is 15 times greater than the combined weight of literally all the cars on the planet. And finally, compared to buildings on Earth, 33 billion tons is equal to several large metropolitan areas made entirely of steel and concrete. But the whole idea of how big this comet is fades in comparison with an even crazier fact about it. It could be unknown technology from a different galaxy, and some experts are somewhat sure about that. But why? 3I Atlas was first spotted in July by NASA's Asteroid Terrestrial Impact Last Alert System. A bit later, the US Space Agency confirmed that the object was an interstellar object, only the third we have found so far. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But the newest comet, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which is just a quarter-mile long, and Borisov, which is about 0.6 miles across. By the way, some believe that the comet could be even bigger, up to almost 7 miles, but scientists haven't found any proof of that yet. Besides its size, 3I Atlas is different in other ways too, which makes some scientists question its origins. The object is shedding huge amounts of carbon dioxide and dust while zooming towards the sun. It's most likely the proof that 3I Atlas is more massive than the other two interstellar objects by 3 to 5 orders of magnitude, which is basically a serious anomaly. The comet is also traveling toward the sun incredibly fast. We're talking about around 130,000 miles per hour, which is almost 170 times the speed of sound. Another weird thing is that this interstellar object is following a straight trajectory, unlike anything else in the solar system. Most space bodies move along curved orbits due to the force of gravity. That made some researchers believe that 3I Atlas might be a probe sent by another civilization to explore Earth, possibly with not-so-friendly intentions. Their theory is that the object could be a technological artifact, a sign of cosmic intelligence. You see, the comet moves in a pretty weird way that doesn't totally line up with just gravity. Its trajectory also takes it close to Venus, Mars, and Jupiter. And researchers think that these planets might be especially interesting for another civilization to pass by. Another bizarre fact, the space traveler also spins backward compared to most stuff in our solar system. This might be necessary to make it easier for 3I Atlas to get near Earth without much resistance. Some scientists think the comet's odd spin and flight path could help whoever or whatever made it take super precise measurements of the planets, things like their orbits and sizes, to plan a perfect route through the solar system. If 3I Atlas suddenly changes direction in a big way, that might mean it's using some kind of built-in engine instead of just drifting through space. There's also another theory that suggests it could be a piece of unknown tech that's still active. There's no need to worry though, at least at the moment. The comet isn't coming anywhere near us. NASA says it'll stay around 150 million miles from Earth when heading toward the Sun. So the question is, where do such space visitors come from? Astronomers have found that the 3 interstellar objects we discovered came from totally different parts of the galaxy. And each of them has its own age and background. 3I Atlas turned out to be the oldest, about 4.6 billion years old, and it came from the Milky Way's thick disk. That's a region filled with older stars that have fewer heavy elements. 1I Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. Oumuamua, Hawaiian for a messenger from afar arriving first, was the first known object from another star system to pass through our solar system. Basically, the first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. It also sped up in a way that couldn't be explained by gravity alone. Changes in brightness showed it was tumbling end over end instead of spinning smoothly. At first, scientists were confused because the space body didn't have a tail or cloud of gas like a normal comet, even though it was accelerating. That led to a lot of debate about what it was made of and where it came from. Just like with 3I Atlas, some people wondered if it could be technology created by a space civilization. But most scientists now think Oumuamua was a totally natural object, just a really weird one. The best guess is that it was a comet releasing invisible hydrogen gas, which caused it to speed up slightly. Sadly, by the time astronomers found it, it was already heading out of the solar system, so there wasn't much time to study it. As for 2I Borisov, it sits in between at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. The comet was discovered in 2019 by Gennady Borisov, an amateur astronomer who actually built his own telescope to search for faint space objects. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma. That's a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the sun. Plus, it boasted a long tail of dust and gas. Studying 2I Borisov helped researchers learn more about how other planetary systems form. Observations showed that its dust grains were compact and that the amount of gases like carbon dioxide changed a lot as it approached the sun. It could mean that the comet formed under very different conditions than anything else in our solar system. Now, 2I Borisov is speeding away from the sun and will never return. But it allowed scientists to take a unique glimpse into the chemistry and history of distant worlds. Interestingly, the differences between these 3 space objects suggest that interstellar visitors have been getting kicked out of planetary systems all across the galaxy for billions of years, so it's not something new. To figure out if 3I Atlas might be some kind of probe from another planet, scientists are checking for any signs of technology, like strange radio signals, electric activity, and weird movement patterns. If the comet suddenly changes course or drops smaller objects nearby, it might be our cue. But even though 3I Atlas is moving in a pretty wild and energetic way, it's most likely just a natural interstellar object passing through. Researchers say they'll need a lot more proof before anyone can seriously say the space wanderer was sent by someone from another planet. What do you think about this newly discovered space traveler? Share your opinion in the comments.
Picture a silent ember drifting toward the sun, moving so quickly that no gravity well in our system can bind it. That ember, provisionally tagged 3I Atlas, appeared in late June when the Atlas Hazard Survey cameras in Hawaii and South Africa logged a faint, fast intruder. Initial orbital fits showed an eccentricity greater than 1. the mathematical stamp of an origin beyond the sun's reach. We have met only two such emissaries before, One-Eye Oumuamua in 2017 and Two-Eye Borisov in 2019. Now a third arrives, tugging at our curiosity and our instruments in equal measure. The object's present speed is almost 70 kilometers per second, enough to span New York to London in 90 seconds. Backtracing the path leads toward the constellation Lyra. Forward projection shows a swing past Mars on 3rd October 2025, a solar perihelion 20 days later at twice Earth's distance, and final escape by early 2026. Earth stays on the sun's far side throughout, so the risk ledger reads 0. The intrigue ledger, however, is packed. Composition sits at the top of the to-do list. A comet would sprout a gaseous veil as ice evaporates, yet deep imaging has yet to reveal any coma. An asteroid would follow purely gravitational curves, yet a whisper of extra thrust may lurk in the astrometry. The James Webb Space Telescope can cut through reflected sunlight and sample the infrared glow for water, carbon monoxide, or exotic minerals. If the spectrum comes back featureless or metallic, theories multiply. Brightness fuels the puzzle. Even with a modest albedo, the observed flux implies a body several kilometers wide, far larger than Oumuamua, whose size was measured in hundreds of meters. A highly reflective hull could achieve the same luminosity with far less mass, a possibility that keeps techno-signature specialists awake. Professor Avi Loeb, already known for suggesting an artificial origin for Oumuamua, is lobbying for continuous JWST tracking to test for non-gravitational acceleration. A persistent drift unaccounted for by gravity would demand explanations that push against the boundaries of conventional astrophysics. Statistics pose the second riddle. For centuries, astronomy recorded 0 interstellar passers-by. Now we count 3 in 8 years. Better sky coverage explains part of the surge, yet simulations indicate the detection rate is still high. Either the density of galactic debris is underestimated, or transient swarms are sweeping the sun's neighborhood. The Vera C. Rubin Observatory, starting full operations next year, will clarify the odds by mapping every moving speck down to faint magnitudes every few nights. Structure forms the third unknown. Light curve monitoring can reveal whether 3i spins like a platter, a spindle, or a rubble pile loosely bound by microgravity. Oumuamua's flattened shape and unexplained kick remain controversial. A repeat would strengthen calls for new physics or new engineering. Rapid tumbling might indicate past collisions, freshly exposed ice, or even deliberate attitude control. That opportunity extends well beyond the object itself. Each interstellar visitor carries isotopic fingerprints of the chemistry that shaped alien worlds. Sampling those fingerprints, even remotely, refines models of planet formation, volatile delivery, and the migration histories of giant planets. In a decade, robotic missions may be fast enough to intercept such bodies. Today, we practice with photons. Time is tight. By September 2025, the object will vanish into solar glare. By the time it re-emerges, the outbound leg will dim below major telescope thresholds. Roughly 5 months remain for the most ambitious observations. Teams are coordinating radar pings, ultraviolet spectra, and high-cadence photometry to squeeze every bit of information from the fleeting visitor. Why should the broader public care? Because 3i Atlas is a tangible reminder that our solar system is not an island, but a crossroads. Somewhere, an unknown star flung this body into the dark, perhaps through a near miss with a giant planet, perhaps through a cataclysmic collapse of a binary pair. After wandering for millions of years, it has brushed past our doorstep, offering a message in a bottle. The galaxy is bustling, and we are part of that bustle. Whether the newcomer proves to be ice, rock, metal, or something unprecedented, its brief appearance renews a sense of frontier. Sky surveys sharpen, theories adapt, curiosity deepens. The next discovery may come sooner than anyone expects, and when it does, the groundwork laid today will allow us to read its story more clearly. For now, astronomers chase a streak of light across CCD frames, and every clear night might deliver a clue that rewrites chapters on planetary science, or adds a footnote to the search for artifacts among the stars. In either case, the sky is not done surprising us. Origin scenarios abound. Some simulations eject 3i from a nascent planetary system after a close brush with a giant planet, while others invoke a crowded stellar nursery where passing stars fling debris across interstellar lanes. Whatever the trigger, the body has drifted for perhaps tens of millions of years, carrying the isotopic signature of an alien chemistry lab. Radio arrays will also listen for narrow-band emissions, more out of thoroughness than expectation. After Oumuamua, techno-signature protocols are standard. Scan, archive, move on, unless a signal repeats. Looking ahead, Rubin's legacy survey of space and time should uncover several interstellar objects every year, identified early enough to permit rapid robotic flybys. Concepts under study at multiple space agencies outline launch-on-alert missions that could sample surface dust or even return grains to Earth. Each discovery thus acts as rehearsal for the day we chase one down in person. Whether the outcome is ordinary or transformative, the chase itself pushes instruments, sharpens global teamwork, and teaches the next generation to aim beyond yesterday's limits.
Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did the zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space. Thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow. You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces, and this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid's surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, Astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny, but it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth. So this thing, Cosmos 482, a high-tech capsule, was built to survive even the most extreme heat of another planet. But something went wrong. It never made it out of Earth's orbit. For over 50 years, it drifted silently around the planet, forgotten until now. In May 2025, gravity finally pulled it down. It's coming home, built to survive re-entry and unpredictable enough to crash anywhere. No warning, no parachute. Just a 1,000-pound sphere falling from the sky, a human-made meteorite capable of causing chaos. In 1972, this funny-looking ball was sent on a Venus-bound mission. Now, Venus is like Earth's evil twin. It's similar in size, but that's where the similarity ends. It's the hottest planet in the solar system, where temperatures reach 860 degrees Fahrenheit, hot enough to melt lead. Atmospheric pressure is about 93 times greater than Earth's, which is like being 3,000 feet underwater and you feel like you're in a trash compactor. And the atmosphere itself is made of carbon dioxide, with clouds that literally rain sulfuric acid. So yeah, it's pretty bad. Yet Cosmos 482 was fully expected to reach it and land. Not for long though. A type of self-destruct scouting mission. The spacecraft was designed to land and transmit data, hopefully for at least a few minutes, on the surface that crushes, bakes, and basically dissolves anything that touches it. How? Well, it came with heat shields for the fiery plunge, a mini AC to cool just long enough, and armor tough enough to handle Venus's brutal environment. It was truly a high-tech reinforced vault built for a one-way trip. And this was in the early 70s, mind you. Fun fact, even today, we've never built anything that could survive that kind of environment. We have deep-sea submersibles that can handle big-time pressure, but not the heat. There are space capsules that can withstand extreme temperatures, but only for a few minutes. Even nuclear reactor walls, designed to handle serious pressure, would crumble if acid rained on them nonstop. Now, a funny twist of this story is that landing on Venus was already achieved in 1970. Venera 7 became the first spacecraft to land on another planet and transmit data back to Earth, surviving on Venus's surface for a full 23 minutes before melting down. It proved the impossible was possible, just not for Cosmos 482. So, what went wrong with Cosmos 482? We've always imagined space travel as firing up the spaceship, launching it, and that's it. However, that's not how it works. First, with an initial boost, you park it in Earth's orbit, like pulling into space's driveway. Then comes a second burn, a precisely timed engine firing that pushes the spacecraft out of orbit and toward its destination. Cosmos 482 made it to the parking orbit just fine, but something went wrong with the second push. No push means no trip, so instead of heading to Venus, it got stuck circling Earth for the next 50 years. But why does something get stuck orbiting for so long? Well, when something gets launched into space, it's not just going up. It's also going really fast sideways. If you throw a baseball up hard enough, it'll eventually hit the ground. But if you could throw it fast enough and Earth wasn't in the way, it would just keep falling around the planet. That's what orbiting means, falling but never hitting the ground. The object's forward speed balances perfectly with the gravity pulling it down. So, to leave Earth, a spacecraft needs to pass through 3 layers. The first is low Earth orbit, or LEO, a few hundred miles up. Here is where satellites, the space station, and tons of leftover junk circle the planet. Cosmos never made it past this point. If the second launch had been successful, it would have gone through medium Earth orbit, where GPS satellites cruise. Then, way out at 22,000 miles, there's geostationary orbit, the sweet spot for weather reports and TV. So now we know how Cosmos ended up there and why it was orbiting for so long in LEO. But what made it suddenly change its mind and fall back? Even in LEO, space isn't completely empty. There's still a tiny bit of atmosphere up there, and over time, it acts like a brake, slowing things down just enough. Think back to that baseball you threw sideways fast enough to orbit Earth. Eventually, it will slow down to the point where gravity takes over. However, Earth is securely protected by its atmosphere. As objects fall back to Earth, their speed keeps increasing up to tens of thousands of miles per hour. When you're moving that fast, the air pushes back really hard. That push creates friction, and friction creates heat, a lot of it. The surface of falling objects can reach over 3,000 degrees Fahrenheit, causing them to melt, shatter, or vaporize completely before they ever hit the ground. That's why scientists don't lose sleep over small debris. Small pieces of old satellites, even tools lost during spacewalks, fall all the time. But they burn up like shooting stars. We just never notice them. Now, a baseball would disintegrate instantly. But what about a giant ball designed to withstand landing on Venus? Thankfully, this potentially horrifying story is anticlimactic, because Cosmos crashed into the Indian Ocean west of Jakarta on May 10, 2025. Radar picked it up streaking through the sky, glowing, breaking, heating up, but still intact enough to make it all the way down. And it did, thankfully, not somewhere crowded. However, now that it's lost beneath the waves, we are free to speculate. How real was the danger? Could it have fallen into a crowded area? Absolutely. If that 1,000-pound capsule had come down over a city, it could have smashed through rooftops, wrecked cars, or worse, seriously injured someone. And no, there wouldn't have been sirens or alerts. Cosmos 482 was launched in the 1970s, long before GPS or live tracking, so there was no signal to follow, no proper guidance system. Scientists could only make rough estimates about where it might land, so if it had come down over land, it would have looked like a meteor. Well, the story of Cosmos, with the K, had a happy ending. But it's not the only thing up there that could fall down. As of early 2025, about 11,700 satellites are active. But with roughly 14,900 in orbit, that means over 3,000 are no longer operational. And the space junk keeps piling up. Space tracking systems monitor more than 40,000 objects that are bigger than a softball, such as pieces of old satellites and bits of rockets. Scientists estimate there are over 1 million fragments larger than a half an inch, and more than 100 million smaller bits still floating around. These can't hurt us down on Earth, but most of it clutters LEO, where collisions can generate explosive clouds of debris, damaging satellites and space stations. Just one crash can trigger a chain reaction called Kessler syndrome, where each impact creates more debris, leading to more collisions until Earth's orbit turns into a demolition derby. Remember the movie Gravity? Yeah, like that. And yes, bigger things from LEO do fall. Cosmos 482 wasn't the first space object to come crashing back. In 2016, Tiangong-1 space station lost contact and tumbled back to Earth 2 years later, eventually burning up over the Pacific. In 2001, the famous Mir station was intentionally brought down. And before that, in 1991, Salyut 7, another space station, unexpectedly deorbited. The 40-ton station broke up on re-entry, and parts that survived scattered over Argentina. Among others, in 1979, NASA's Skylab, the very first American space station, fell back to Earth with only partial control. Pieces of it rained down across Western Australia. Some newspapers even offered cash rewards to anyone who found a chunk. So, we've seen this happen before. Cosmos was just the latest reminder. But NASA and other space agencies do think about this problem. And most modern spacecraft designed to return have parachutes, heat shields, and built-in safety systems to guide them home, but not working satellites and old junk. Yeah, they're still up there. So next time, a space object might not land safely in the ocean. It might crash through your roof while you're watching a Brightside video. But don't worry. Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So, what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the Comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space.